Hello everyone. So this is the third video of the Spiral Galaxy visualization series. So in this video, we are going to create uh, the visualization that you're seeing here. So the stars are moving in their respective elliptical orbits in the galaxy. So for creating this one, we are going to take the code for this visualization and we'll add certain pieces of code into this to slowly convert this into this. So let's look at the code for this visualization. So first I'm going to create a duplicate of this one, and then let's just think about what is it that we want to do. So for each of the elliptical orbits, we need a star, and we need the star to move in the elliptical path. And for that, we need to have instantaneous position for each of the stars. So for doing this, we have to create a star class, which is what I'm going to do first. Class star, and in the constructor, I'm passing the major axis length. So as far as a star is concerned, the only thing that we need to know about it is the uh, size of its orbit. So it will be size of the major axis of the elliptical orbit. So I'm going to store this into a variable. This is len. And just as we did before, I'm going to derive the length of the minor axis from the major axis. Into width height ratio. Okay. Next, I'm going to create a display function. So this is for displaying the star on the screen. So for this, we need to know the x and y coordinate of the star. So for this, we are using the parametric equation of an ellipse, which is x equal to a cos theta and y equal to b sine theta. So theta is the parametric variable, and a and b are the length of semi-major axis and minor axis. And what happens if we vary theta gradually? So if these are the x and y coordinates, and this is the ellipse, this is the theta, these are the coordinates a cos theta and b sine theta. So if we vary theta, what happens is the point gradually moves in the elliptical path. So that is what we want. We want the star to move in the respective elliptical orbit. So I'm going to determine the x and y coordinates of the star. So for that, by 2 into this cos of this dot theta. So I'm going to create a theta variable equal to 0. So why do we have this divided by 2 factor? This is because the parametric equation of an ellipse is a cos theta, b sine theta. A and b are the semi-major axis, not the major axis. So we have to divide the length of the major axis by 2. And then we have the y coordinate, which will be this dot minor axis len by 2 into sine of this dot theta. And then I'm going to draw the circle which represents the star xy 5. I need the fill of the circle to be white, and I don't need any stroke for the star. Okay. Next, we are going to create an array for storing the instances of the star objects. So For each of these ellipses, we need to have an instance of a star. So all those instances will be present in this array. So we are going to initialize the instances of the stars. For that, I'm having a for loop here. I less than number of stars. Number of stars will be equal to this value. And I plus plus stars dot push new star. So what is the constructor of the star class accept? It is the major axis length. So we have the major axis length already calculated here. I'm going to take this and put here. Okay. And then I'm going to comment this and this. And I'm going to display the ith star dot display. Okay. So now we have the our stars displayed on the screen. Why do we have this strange curve here? So I will explain the reason. So one of the reason is that we have this theta variable 0, and another reason is that we are rotating. We are doing a rotation here. So if this is the axis, so in P5 this is the plus axis, and this is the plus x axis, and this is the plus y axis. So so first, for the first iteration, we are doing a small rotation. Okay, we will be having a very small rotation, and then we are drawing the star at a cos theta and b sin theta. Theta is 0 here. Okay, a and b are some finite values. So the x coordinate will be a non-zero value and y coordinate will be 0, and this will be the point. Okay, plus some rotation. And for the next point, the length of the major axis will be greater, and there will be an additional rotation, so it will end up here. And for the next point, it will end up here, and similarly it will go on, and what we get is this curve which we have here. So that is what is happening here. So I'm going to give a random value for the initial value of theta. So theta can vary between 0 and 360 degree. So random of 2 into pi. Okay, then I'm going to have an update function where I'll be updating the theta. I'm going to have a delta theta equal to 0.01, and then I'm going to update theta equal to this dot theta plus this dot delta theta, and then I'm going to call the update function here, stars of I dot update. Okay, now I'm going to try to increase this value of number of stars. Let's give something like 2000. Size difference will be something like 0.1, 0.2. Okay, then so in this slider, so this rotation gradient will be pi by 2000, which is a very small value, and we have to have this range comparable to this rotation gradient. So what I'm going to do is I'm going to give it 0 here, and I'm going to give here rotation gradient into 5, and I'm going to increase the decrease the steps value. Okay, now I hope you're seeing this spiral pattern emerging. To make it look more like a galaxy, I'm going to decrease the size of this circle, and I'm going to give a transparency to this fill value to 55 to 55, 5500. Okay, so now we have the final visualization of the spiral galaxy. So just as before, I'll be uh, I'll be giving a link to this final code in the description of the video. So just go through the code, go through each steps, and just play around with it. So that's all about this video on creating visualization of the spiral galaxy. Thank you.